Give ordinary people the right tools and they will build the most extraordinary things. That's you guys. I'm expecting extraordinary things from you. That quote was a focusing inspiration in bringing a team together to create Gorilla. I wanted to make it as easy to run online behavioral studies as online questionnaires. I'm sure many of you have experience with Qualtrics. I wanted to give you guys the Qualtrics experience, but for all your behavioral tasks. So that behavioral scientists, that's you guys, could have that increased speed, scale, and reach of online participant pools and ultimately change the world. I'm sure you're aware a lot of the challenges we face in the world, climate change, obesity, tax evasion, these are behavioral problems at their root, and the research that you guys do ultimately feeds into understanding why humans behave as they do, and hopefully will be part of the solution to how we make the world a better place. And I believe we've succeeded. With Gorilla, we have made scientists' lives better. So I'm going to just talk you through this case study with Jade. Before Gorilla, it would take her, and she's got the GitHub records here, so I chatted with her about this. It took her 2 months to build a stop signal delay task in MATLAB, and plenty of tears and frustration. And then it took her 6 weeks to recruit 50 participants in the lab, maybe testing 3 a day, several days a week. Painful process. And then she switched to Gorilla, and she could build her adaptive stop signal delay task. I've actually got the tweet from her. It took her 1 to 2 hours, but let's call it a day between friends. And then she put her task onto Prolific and collect the 50 participants worth of data in an hour. She could have collected 500 participants worth of data in an hour, but let's call that a day between friends as well. So out of this 3-month block, what used to be 98 days, that's all gone down to 2 days, saving her 3 months of time and 3 months of salary and 3 months of frustration. So all of you in the room, if you'd like 3 months of your life back so that you can focus on reading the theory, focus on having a holiday, focus on going home on time, getting some exercise, then Gorilla might be something that can help you do that. Hi, I'm Jo Evershed. Matt very kindly introduced me. I'm the CEO of Gorilla Experiment Builder, and I also host the Behavioral Experiments online conference. Today what I'm going to do is I'm going to explain what Gorilla is and the types of things it can do and how it's different to the other solutions you may have come across, and tell you a little bit about how we think about creating the best possible tools. This is probably the start of a conversation. You'll find out more either by coming to an onboarding webinar or by chatting to me directly, because all of your specific research is of course very specific to your research. So in this talk I can only talk about some of the generalities that apply to all of you. So what is Gorilla? You want to run an online study. You're going to need your consent form, you're going to need a demographics questionnaire, you're going to need your actual tasks, whether they're surveys, reaction time tasks, games, multiplayer tasks, shopping tasks, something else. You're going to need your randomization and counterbalancing, your experimental controls. You're going to need your hosting and data collection so that all of your data is stored somewhere and securely. So you're going to need your security and compliance. And as you can imagine, Cambridge University has some quite stringent policies there. And you might even want some open science publishing so that once you've finished doing your paper, you can publish it online for somebody else to copy or inspect. You're also then going to need some participants to take part in your study, and you're going to then, once you've downloaded the data, you're going to do your data analysis, whether that's in SPSS or R or Python or whatever you choose. At Gorilla, we do this whole bit in the middle. So you'll need to get your participants from somewhere else. It could be that they come to the lab. It could be that they're from Prolific. It could be that they're via a charity. We don't mind. But we do this whole bit in the middle. So where that makes us different from someone like Qualtrics, which you understand, they'll do this whole bit in the middle, but they only do surveys. They don't do tasks or games or multiplayer related experiments. Or it might be similar to, that's probably the closest equivalent, to be honest. So why choose Gorilla, or why have the CBU chosen Gorilla? At Gorilla, we think, you've probably heard this thing, right? That if you want to be good at something, you have to focus on 3 things. And if you focus on more than 3 things, you're just trying to do too much. You need to just focus on the 3 things. Everybody familiar with that idea? So these are the 3 things that we focus on at Gorilla. 1, we want to make our software as powerful as possible. We want to make it powerful so that you can do what you need without being technically constrained. It just makes me sad to think that science is being constrained by the tools that are available. We want to make it easy to use so that you have time and can focus on the science and not the programming. Again, it just makes me sad to think that the people who can sort of play when it comes to science is being constrained because they don't have the technical capacity themselves. It's sort of undemocratic. They're being told, no, you can't ask these research questions because you don't have the skills to make the programs work. And we wanted to make sure it was really well supported so that you're never lost and alone. And this was really important to me sort of personally and to the company. We'd seen PhD students who get lost and alone and frustrated and scared and anxious, and I didn't want people to be in that situation using my software. I wanted to be part of the solution. So we have a really, really well supported platform. I'll talk a little bit about that later in more detail, where you're talking to other experimental psychologists so that you're never lost or alone. If you've got a question, you're going to have an answer from one of us really, really quickly, so that you don't get stuck. And so I think that it was these three reasons together, which is why the CBU chose to go ahead with a subscription to Gorilla. Let's have a look at those in more detail. What does powerful mean? So with powerful, we wanted to make everything available in one platform. So we have a survey tool in Gorilla. We have a task building tool for building reaction time tasks in Gorilla. We have a game building tool, which allows you to put on particle effects and animations so that you can make your tasks more fun and enjoyable for participants to take part in. I know nobody likes the idea that their participants are bored of their studies and are not enjoying themselves. We have a shopping simulation that you can use in Gorilla to ask those more consumer psychology related experiments. It's probably not for anybody here. We have a multiplayer tool so that you can run those classic multiplayer studies, but also put maybe different types of research into a social context. It sort of sometimes surprises me that language research is often done one person in a lab looking at a computer, whereas of course language is inherently a social thing. So why don't we study language in a social context? It's because the technology hasn't been available. It hasn't been easy enough to use that language researchers have had it readily available. By making it readily available, we hope we can extend the types of questions that you can ask and answer. And then we have a code builder as well. The code builder means that if you can write JavaScript, you can create anything you can possibly dream of. If you wanted to create a keyboard with a piano and people play music and copy it back, knock your socks off. You can create whatever you can imagine. So that's how we make it powerful. How do we make it easy to use? The way we focus on making everything easy to use is we have a user interface. And across all of our tools, the user interface is consistent. So once you've learned how to use one of them, you've learned how to use quite a lot of all of them. So it doesn't feel like an overwhelming task. Compare that to how it feels today, where you've got one tool for surveys and one tool for this and one tool for that and one tool for another, and you're constantly going, oh, do I remember how that works? Can't quite remember where that setting is hidden. UIs are wonderful because they are easier to understand, they're faster to work with. We can link you to the built-in documentation so that you get the support you need when you need it. The thing that people worry about with a user interface is what happens if I get all the way to here and then discover that Gorilla can't do the thing that I need, and I have to go back to the drawing board and pull it all out and start again writing in code. So what we do with our tools is we make them extensible. We make them scriptable when necessary. Our tools, and I'll show you a video of this later, they have a scripting pane where you can click on it and you can write your own JavaScript and you can augment the functionality of Gorilla yourself so that you can make it do exactly what you want it to do. I rather love this quote from Priya Silverstein. Wow, I love Gorilla. I was just messing around trying to see if it could do what we needed for a project, and I ended up creating an entire demo version complete with all the counterbalancing, ready for the real stimuli to be added later. It's so intuitive and clear. And then the third thing is the fully supported. So we have a team of psychologists who are available to support you at Gorilla. So there's Jade, who has a postdoc in experimental psychology. Johanna has a PhD in psychology. Claudia here has, oh, you can't see my mouse. Claudia has a, I think I could do it like that. Does that do it? No, it doesn't matter. Anyway, the one in the middle. I can do it like that, actually. There you go. Claudia has a master's degree in psychology. Megan is doing a master's degree in psychology, and Hannah has a BSc in psychology. So when you're writing a question to one of our support desks and going, I'm struggling this, and it's important because that they understand where you're coming from. You're not just talking to people who don't understand what's happening. The way your typical interaction with our support team would work is that you're using our tools initially, and then you'd get stuck, so you'd look at our support docs, and whatever zone you're using, it will link you directly to the support docs. You'd read them, but if you get stuck, there are videos, there are tutorials, there are samples. If you get stuck, you can contact our support desk. We mostly answer within 24 hours. We give ourselves up to 48 hours to answer you, so you're getting a really fast response in terms of our replying to your questions. Once a week we run office hours, which is like office hours here, right? You can jump in and you can get on a live call with our team and they will get you unstuck. And then we run regular webinars as well, whether they're onboarding webinars, scripting webinars, game builder webinars. I think we're creating a new one called Conditions and Controls, but they'll be very well supported. I quite like this quote from Muhan Lee. Gorilla rescued my dissertation. They have the best support team in the world. I'm sure it's not entirely true, but I like the sentiment. Okay, so that takes us to an overview of the tools at a high level. So now what we're going to do is jump in and look at some of the tools in more detail so that if you sign up to Gorilla and you're having a look around, you've got a mental model of what exists. So let's first talk about the experiment tree. Here you go. So as I've already mentioned, one of the things that makes us different from other tools is that you have all of these different tools within one platform. So you need to be able to link them together. You need to be able to send somebody from a questionnaire to a task, then from a task back to a questionnaire, then from a questionnaire back to a game. And you need to be able to orchestrate that whole experiment, what we call the experiment. And so that's what our experiment tree does. Here you start at the start node, and then we've got our consent form and our demographics form, which are built in our survey tool. And then here there's a relational reasoning task, and then an affect task. So that's a simple within subject experiment. What's nice about this modular design, I'm sure this is not new to any of you, you often reuse little bits of an experiment between experiments, don't you? You reuse your consent form, you reuse your demographic form. You might have a standard task that your lab reuses lots of different times, but you change the stimuli in it, or you change the duration of it. So what's nice is you can publish each of these components separately to your team library, to your department library, and then rather than having to build it from scratch each time, you can go, oh, I'll just take that, I'll put it into my experiment. I know people who have created experiments 50 to 60% created with materials that other people have created, and they just slot them in and use them. So this would be a within subject design. And then on top of the experiment, so within the experiment tree, to allow you to manipulate where people flow, we have some really useful nodes. So here there's an order node, and here there's a randomizer. The order node means that 50% of the participants would get their relational reasoning task first, and then the affect task, and 50% of it would get them the other way around. So a classic counterbalancing node. If we had a third one in there, there would be 3 that are shuffled, and one of the settings in there is that you want it to be the Latin square shuffling for all pairwise contrasts, so you just turn on the setting that does the thing that you generally need it to do. And here's our randomizer. Again, this is set up to be balanced at the moment, where you have 50% of your participants going that way and 50% of them going that way, but it's not a statistic. You can have it as a statistical 50%, but actually this one is set up to be balanced, which means that in a group of 20, 10 will for sure go that way and 10 will for sure go that way. So it's like you've got a deck of cards that you're handing out and people get allocated to the condition. And then, of course, you can put these nodes together to create, let's say, a randomized controlled trial. So here we've got a pre-test and a post-test with 2 different stimuli sets. This is actually the same task. It's exactly the same task. I know you can't see it really on the screen, but just with 2 different stimuli sets in it. So we're saving you the bother of having to rework it. Counterbalanced, so you've got a group 1 and group 2, and half will get it the other way around. And then within the randomizer, you've got half going to a control condition and half going to a treatment condition. What people say they really like about this is how they think about experiment design. This is what they draw out on a piece of paper, and it's really nice to have a system which reflects how they think about it, because it makes them feel completely confident that they have, in fact, programmed Gorilla to do the thing they want it to do, because this is how it's reflected in their heads. And then we have a few other nodes as well, which allow you to do really more powerful things. The one that I think you guys would be most interested in is the repeat and delay nodes. If you want to do multi-day training studies, here you have a repeat node and a relational reasoning task, and then a delay node where participants can type in an email address, and then at the end of that, they hit the repeat node, and they come back, and they could do 3 days of training, they could do 20 days of training, however much you want, but you just set it up once and let it run. Gorilla will do the emailing to tell them to come back and take part again. You could set this up with a pre-test, and then 20 days of training and a post-test, all in one thing. You could set it up with a pre-test, 5 days of training, and then middle test, which happens on a weekly basis, and then loop that 4 times, and then a post-test at the end. So you can get this tremendous wealth of data of where the benefits are coming from a training paradigm, but without you having to do that manual follow-up of chasing everybody down. So that takes me to the end of the bit about the experiment tree. So next we're going to look at the task builder, which I think is the tool that is going to be the most useful for you guys here at the CBU. So the task builder is the tool that you'd use to create the Stroop task, an IAT, a go-no-go task, an MBAC task, mental rotation tasks. You could also use it for interviews if you just wanted to get a large corpus of text inputs or video recordings or audio recordings from participants that you could then mine in different ways. So it can be used for both quantitative and qualitative research. So how is it that we're able to build all of these different things? It's because Gorilla is built around a system of components. And there's a limited number of components that you can put onto a computer screen. We can have text, images, audio, video, animations in terms of the stimuli. In terms of responses, we can get inputs from the mouse, from the keyboard, from a touch device. We could get inputs from the webcam. We could get inputs from the microphone. We can have drag and drop. We can have drawing inputs from a mouse or from a stylus. And then you're going to need these bits which link it all together, so giving your participant feedback on their accuracy, their speed, and their progress. And with these different building blocks, we think of them a bit like Lego building blocks, you can create anything you want. You can create a little house, you can create a car, you can create the Harry Potter whole thing. Like, it's totally up to you what it is that you want to create. And just so that you've got an idea of what that looks like under the bonnet, essentially, we've tried to use a visual language which you would all be familiar with. So the bit that lays out the screen is sort of similar to PowerPoint. You say which zones that you want, and you put them on the screen, and you drag them and reshape them and put them where you want to display, but that's not dissimilar from PowerPoint. Then you can link this zone, so here I'm linking this zone to the spreadsheet, to this column puzzle, that's what that bit there means. And so then I have a spreadsheet, which you're all familiar with, because you all use Excel, to list out what content you want in each trial, right? What image you want here in the puzzle, and which image you want in each of these response options. And then you can set up the randomization on these images, and then you need to have a place where you can upload all of the images so that Gorilla can tie them all together. So this should feel fairly familiar. There should be an animation on that screen, but it doesn't seem to be coming up. Anyway, this is quite like PowerPoint, this is quite like Excel, and this is a bit like Explorer, so where you list all your files. Let's have a look at some videos of how this all stitches together. Let's see, how do I get this to play? Do I? Thank you. There you go, that's doing it. Right, so this is how the spreadsheet looks. So here first it's going to say, show this instruction screen, then show these trial screens, and then show this finish screen. This is the content of all of them. We're going to always show this first trial first. It doesn't have a one next to them. And then we've got these 6, which we're going to show in a shuffled order. And you can preview the randomization just by clicking this button to convince yourself that the randomization that Gorilla understands that you want is in fact the randomization that you want. Because that's, again, one of the things that people worry about. You can tell the computer to do it, but you want to be certain that it is actually doing the thing that you asked. And it's nice to be able to preview it. And you can go and look at the stimuli here. You can search for them. You can filter for them. And this is the bit that's more like PowerPoint. So this is the layout of the instruction screen. With an image and some text and a next button. And then this is the layout of the trial, where first we show a fixation screen, which looks like this. And then after that, we show the main screen, which is the key screen, where you're going to collect your behavioral responses. Now, let's have a look at what setting this screen up in particular looks like. There you go, the trial setup. Is that playing? That's playing now. Brilliant. So once you've put in that's an image zone. You can see it's an image zone here. You can drag it about. You can put it where you want. You can resize it. And it just dynamically shows you exactly what the participant would see. They wouldn't see it with all of these dots, etc. And then when you're happy with the way that it looks, you can preview what that you can add an object. Sorry, that's the next bit. So let's add some text. We go and click on the text objects. We add it to the screen. We can type in some text. Here we're going to add some instructions, which is the missing piece, question mark. And then we can drag that to where we want it to be. We can resize it. And then we can increase the text size to whatever we want it to be. And we can change whether it's left, center, or right aligned. And then we can preview what that's going to look like on different monitors. Because if you're putting this online for anybody to take part in, you're going to want to make sure that your items aren't overlapping, that something's not obscured. So that's really reassuring as well. And then you can see what it would look like to the participants. This is how you'd actually preview the whole task, but here you can preview just an individual trial, and then when you click on an answer, here I'm going to click on the wrong answer, and you can see how Gorilla is processing those responses. So this is another place where people sometimes get nervous about moving away from code. What's nice in code is that you can step through with the step function and see exactly what's happened, but we've added this debug panel onto Gorilla so that you can see what's being stepped through, what Gorilla is interpreting, which makes it much easier to understand where something's being misunderstood. And it makes it much easier for us to support it as well, because we can look at it and go, that's what's missing. Or you can say, this is the error I'm getting. What does that mean? And we go, this is the bit of documentation that you need to access. Let's look at adding functionality above and beyond this. So here, let's look at adding an object. We're going to add a feedback object. So you just go and find the feedback component, you add it to the screen, and that's it. That's all you need to do. The feedback component knows that it should pay attention to correct and incorrect answers, and it should show a tick for correct answers by default and a cross for incorrect answers by default. You can, of course, change those images, right? But that's all you have to do. It's this idea of there's a Lego building block to do the thing that you want to do. It's that simple. And as long as you have faith, you're going to find it. So that's how you'd add a feedback zone. Let's have a look at adding a timer. So a timer's a little bit more complicated, but not a lot more complicated. We have to do two things to add. Is that playing? I'm not sure. Yeah. Yes. So we have to add two components. One, we need to add a time limit to the screen. So we're going to add that. So that means that there's then the screen will end automatically and it will move on to the next trial. We're setting that to 5 seconds. And then we need to add an object, which is the countdown, which is here, and we could add that to the screen, and then we place that where we want it to be, and set the text size so that we can see it. And I think that's now improved, that the default is now a decent size. And now when we preview the screen, we can see that number count down, 5, 4, 3, 2, 1. Slightly out of time there. And then you see that the response was processed as a timeout. So that, again, is just you find the component that does the thing that you need, or the collection of components that do the things that you need. If you wanted to add a progress bar, there'd be a component called the progress bar, which you add, you lay it where you want it to be, and then you'd need to put a setting into the spreadsheet to say which trials should increment the progress bar. So what's nice about that is we can add quite complex functionality to Gorilla, which doesn't clutter up the UI, because it's not there on the screen by default. You have to decide, I want that complex functionality before it gets added to the UI through the component system. But that's how we added staircasing for the story that Jade you saw at the beginning. The staircasing component knows that it needs to store the count of correct and incorrect answers, and then it needs the criteria for stepping up and down that value. So you just go through and fill out all of the fields here, and Gorilla will do the heavy lifting. Similarly, if you wanted to do screen branching, which is often very common in sort of statistical learning tasks, where if the participant responds in this way, go there, but if they respond in that way, go there, you just add the screen branching component and you send them to different screens, which you've laid out. And then we have components for lots of advanced functionality as well. We've got components for eye tracking, and there's a virtual chin rest task where the participants who are taking part in your eye tracking remotely are at the right distance from the screen. There's components for mouse tracking and mouse view. There are components for audio simile and audio recording, and there's a headphone check that's built in as well. There are components for webcam recording if you wanted to record babies taking part in experiments and then analyze the video data to do a preferential looking task. People have done it. There are components for drawing tasks, so you can get people to play Pictionary online, maybe with abstract language to see how they represent it in their mind. There are components for getting compound responses, so that if you want people to do a digit span task and they're compounding several answers together. So I rather like this quote from Ben Chomsang. I'm astonished by the range of possibilities, and the way we make that possible is with this component system, that you add the little Lego pieces that you need to your task. Now, I promised earlier I'd show you a little bit about scripting. So scripting is lovely. What this allows you to do is build your own components, or if you've got a research software engineer in the department, they can build a component for you, and then you can use it within your task. These components allow you to change what Gorilla looks like. It can change the behavior, it can change the response processing, and it can change the randomization, which means to say it can change just about anything. Let's have a look at a video. This is a noddy example, a sort of demonstrative example. This isn't actually functionality you'd add to Gorilla because it already exists in it. But here we're going to create a task component which allows us to change the screen background color. We're going to call it screen background color because we're good at naming things. And here we give you some boilerplate text. This top bit is where your inputs would go. This middle bit is where the code would go that does the screen background color change. And the bottom bit is where you define the user interface. Because even when you script stuff, you still access it through the user interface. So I've pasted in the code that I've pre-written. So here's the bit where we define the UI. And there's the bit which does the actual changing of the screen background. So now let's go back to our task. Here we are. we're going to do the same thing we've always done. We're going to add an object. This object is the one we've just created, the screen background color object. Here it is down at the bottom. It says my component does something awesome, which is what we've said it should say in the UI. And now we have the little bit of the UI here, and we can change the screen background. So that's really cool. That's how you can extend the functionality of Gorilla just by writing a nice little bit of code. There is, of course, I mentioned earlier, there's the JavaScript editor as well, which then anything that you've written in the JavaScript editor, you put inside the experiment tree. So that allows you to create anything that you wanted to do something completely different, which doesn't exist in any of our tools. We have a survey tool, and I think we're pretty much there now. We've pretty much got to feature parity with Qualtrics. So you've got a wide range of question types. There's randomization, skip logic, scoring, localization, the full works. You can do right to left text, and soon you're going to be able to do left to right text. We're just working on that at the moment. But that means you can combine all these different elements really nicely. We also have a game builder. This isn't part of your subscription at the moment, but one of the things that Matt has said is that if there's a lot of demand for it, that decision can be revisited. So Game Builder is particularly useful if you've got either long, boring tasks and you're worried about adults paying attention, or you work with kids and you really need it to be much more interesting because otherwise they're just not going to pay attention, they're not going to play. And I rather like this quote from Katie Mansfield. I've had children at the school coming up to me and saying, oh, can we do the game today? Can we play that game again? I want to beat my score. So that tells you all you need to know about the participant engagement and how gamifying a task that would be traditionally quite boring, quite repetitive, can be made into something that a child will enjoy. So let's have a look at some examples of games that we've created over the years. So this is a game for studying motor neuron disease and the deterioration of motor function over time at a distance. There you just have to pop the balloon as quickly as you can. This one you've got to swat the bees. And so you swat it at the beginning and at the end, and each time we're going back to the origin of the hive, and then you can track how quickly somebody can move between those coordinates over time and see how that deteriorates over a year. Then we've got some other games. These are all go, no go tasks. This was a fun project. Some kids needed to train for 10 minutes a day on the game 4 times a week for 8 weeks. And these kids were, I think, 8 to 11 years old, maybe 7 to 10 years old. And overall, participants completed around 4,000 trials, and they reported they still enjoyed playing the game. So here, you have to click when the gold appears, but if the dragon appears, you have to inhibit your response. So there you go. We've sort of successfully inhibit our response, and we get a gem, and our points go up for our gem. But here, I think we're about to make a mistake, and he roars at you, and we could dial up how much he roars or how little he roars. Now, all of this is created using a user interface, right? You guys would be able to create this level of games, and fairly straightforwardly. This is a nice effect as well. If you notice, the car's not moving during the trial. It's just the cactuses scrolling down the page. And we translate that into the idea that the car is moving, because we know cars move and cactuses stay still. But these are all really easy to program. Has anybody here used the PowerPoint animation engine, where you stitch things together and you make things move? It's about the same level complexity as that. You stitch them together, and then you have triggers which, when this happens, make that happen. And you can make little particles appear. But each little individual bit is really easy, and then you stitch it together into a coherent whole. And then a third game that I can show you, which is quite nice. This is a learning game that we made for Professor Dorothy Bishop. In this one, so kids with developmental language disorder find it really hard to process grammar, like put the chicken below the bed or put the chicken above the bed. So they would click on this button and get an auditory prompt, and this was put the chicken below the bed, and then when they get it right, they get a puff of stars, and then they can go through their game. So in this way, you can get kids to do more trials, because they're going, I'm going through my dungeon, I'm going to do this trial, I'm going to do another one, I'm going to do another one. And you're not making them feel anxious when they get it wrong. You don't say you've got it wrong. There's no big red X on the screen. It's just, oh, it didn't work. Try putting it somewhere else. And then they put it there, and so you get that data. You know that eventually they got the right thing. Maybe it was by a process of deduction. But you know how they responded the first time, and then you can see if they can get better over time. So those are, I think, some of the benefits of Game Builder. Increased participant engagement in kids and adults, and of course, increased participant engagement is the key to good quality data, and good quality data is the key to good quality science, so that's the sort of thread there. You can also use it to test task robustness to surface features and to context. We like to use these games in this black and white context, completely devoid of context, And then we worry about whether the task will replicate into different environments. Well, how about taking that challenge into you and going, actually, I'm going to gamify this task in 3 different ways and put it in 3 different contexts and see whether I get the same results. Because if the contexts matter, then what is it that I've discovered here? Is it robust? So that's a different way of using gamification. And then, of course, if you're into games, you can use it to isolate and investigate actual game mechanics. What's rewarding? What's motivating? What enhances memory? What makes people want to pay attention? What makes people enjoy themselves? So there are lots of different ways of using Game Builder. We also have this lovely multiplayer tool. I'm just going to show you an example today of the multiplayer tool for a classic ultimatum game experiment. So here on the table is $100, and you've offered 50, and then this person on the other side can either accept or refuse. But what's nice is there's a little chat engine in there, right? So you can then collect, and you get all the data of the participants chatting. But you can then also use this to get participants to test each other. So and I think there's one research group which has got this idea of getting people to play Pictionary, right? So here, can you draw this task on the other way? Or how would you describe this thing? You can even give the participants different things to talk, like different instructions, and see how they argue. There are all sorts of mean things that you could do to generate really interesting corpuses of data and to get really interesting behavioral data out the other side. Of course, only with permission from your ethics body on that one. So that's and at the moment, we're in the process of putting video chat into this as well for a particular experiment, so you can have your participants actually chat video to video. I want to say a little bit about open science. Open science is something that's really important to us at Gorilla, and we do a lot of work around that. So part of Gorilla is this open science repository. It's called Gorilla Open Materials. And you can publish anything that you create there. So when let's say you've created your experiment in Gorilla, you've collected all of your data, you're writing your paper, but what you want to do is link to those materials, link to your protocol, and publish that into Gorilla Open Materials. And then in your methods section, you'd go, if you want to inspect my protocol, or if you want to clone my protocol, or if you want to replicate my protocol, here's the link. You can try it yourself. And then somebody reading the paper would just click on their link, and there it is. They can preview the participant experience. They can inspect how the task was set up and look at all the stimuli, and they could clone it into their own project in order to run a replication. And I think you can run a replication in about 3 clicks. At the moment, you can publish experiments and tasks. Then lots of research software engineers have also published scripts. But soon we're working on this next year, you're going to be able to publish components and stimuli, and hopefully one day maybe even data. So if you had a bunch of people all using the same relational reasoning task across the world, and we're managing to publish their data, it's a brilliant way of them being able to write meta-analyses. This is what Gorilla Open Materials looks like. We give you the preferred citation. You can write a little bit of blurb about your piece. It's really very cool. I've lost my cursor. Hang on a minute. There it is. Laser pointer here and here. You can also collaborate very easily. You can collaborate with anybody in the world with a Gorilla account, and it's free to have a Gorilla account. So if you're collaborating with somebody over in the States, that's no problem. And what's really nice about Gorilla Open Materials for research software engineers, and we've got lots of research software engineers who have published things there, is that we take some of that burden around the FAIR principles off them. So the research software engineer writes the new functionality, writes the new components, and they can publish it to Gorilla Open Materials. That makes it findable. And then their duty is discharged, because us as Gorilla will then make sure that it's reusable by other people. All they need to do is clone it into their own accounts. And then if the software they've written is really cool, we might integrate it into Gorilla. And in fact, we did that with a research group here at the CBU. Alex Irvin and Edwin Damalja wrote this amazing thing called MouseView, the MouseView Zone, which is now fully integrated into Gorilla. You are, of course, in safe hands with Gorilla. We've gone through all of the university procurement, but it's safe, secure, compliant, GDPR, consent, everything. So you don't need to worry about that. The decision's already made that. The university's already made that decision. It's also been validated in terms of timing. We've got 2 papers, and it's been published. The timing's been validated in 2 papers and hundreds of citations. And that's it. If you want to take Gorilla for a test run, what I recommend you do is sign up and say yes to the in-app tutorial. And in 5 minutes, you'd have learned to use the experiment tree, and 10 minutes after that, you'll have built your first Stroop task. Come to an onboarding webinar where somebody will take you through in more detail over an hour how to use Gorilla and some of the other screens like participant management and all of that bit. And if you want to chat with me about your particular research, then just get in touch. That's my email address there. And that's it from me today. Just about on time, wasn't I, Matt?
Very good.
Good.